You are welcome for another lesson in physics. My name is Siamasaka Kilian Dennis. I'm going to take you through another lesson. Today we will look at friction again, but we'll predominantly look at force of kinetic friction, meaning that we'll basically use a moving object to calculate actually probably the force and the acceleration. And so basically today we just look at the concepts that will develop, which will enable us to solve any questions related to force of kinetic friction. Here we go. Okay. So today, as I indicated, we are looking at an object moving at an inclined plane. And so, as a matter of revision, we can define again the force of static friction. Whereas we defined earlier, we said the force of static friction is equal to coefficient of static friction multiplied by the weight times cos theta. Okay, and the force of kinetic friction is actually equal to coefficient of kinetic friction multiplied by weight cos theta. And so where are these coming from? We said for an object which is moving downwards, we assume that this object is moving downwards. And therefore, as we indicated, this angle here will be equal to this angle in this right-angled triangle. And therefore, this side would be opposite to this angle, and this other side would be adjacent to this angle. And therefore, if the object, we look at this plane here, if the object is not moving up and down, it simply means that the normal force would be equal to mg cos theta. And the mg sin theta would be equal to this other force, which is along the object, since it is two parallel. And so for an object which is moving downwards, we assume that it's moving downwards, meaning that mg sin theta would be greater than friction, and therefore resultant force we have to subtract from this force mg sin theta. We have to subtract the frictional force for an object which is moving downwards. Okay, and so as we again come back to define the normal force, if you assume that there is an object which is placed on a table and this object is not moving up or down, it means that its weight would be equal to the normal force. The weight of this object would be equal to the normal force. The normal force is the force exerted by the table on the object. And so, as we stated, the normal force here would be equal to mg cos theta. In our case, this is what we are saying. The normal force here is equal to mg cos theta. And so, the force of kinetic friction will basically be equal to coefficient of kinetic friction multiplied by the normal force. As we know that always the friction between objects is directly proportional to the normal force. And therefore, for kinetic friction. For force of kinetic friction, we say that is equal to the coefficient of kinetic friction times the normal force. And we have defined here the normal force that it is mg cos theta. And therefore, we may substitute where there is the normal force Fn here, we substitute it with the mg cos theta. And therefore, the force of kinetic friction will be equal to the coefficient of kinetic friction multiplied by mg cos theta. So if an object is moving downwards, we use again second law of Newton's law, which states that the force is equal to mass times acceleration. And therefore, in our case here, as I indicated earlier, if you want to, this object is moving, it means that this force here, mg sine theta, will be greater than this force, and this one is in the opposite direction, and therefore we have to subtract it. So what we get is mg sine theta minus the force of kinetic friction, which is equal to mass times acceleration. And we said the force of kinetic friction from here, we said it is coefficient of kinetic friction times mg times cos theta. And therefore, we may now substitute this one with mg cos theta, and it gives us mass times acceleration. And therefore, for us to get the acceleration from this equation, we merely make acceleration the subject of the formula. Therefore, acceleration will be equal to what we have on top here divided by this one. And if we simplify, we divide this mass there to cancel with this other mass. And then you can factor out acceleration due to gravity. And therefore, acceleration for an object moving downwards would be actually acceleration due to gravity in brackets sine theta minus kinetic coefficient of kinetic friction cos theta. This is a simplified version of how we would calculate for an acceleration for an object which is moving downwards. Note that this is not a golden standard formula, because the configurations for what is asked can change. For instance, if there was another force pulling along the friction, maybe there was a rope up there, it means that we would have subtracted the two. We would have said mg minus friction minus tension. And therefore, the basic, what is important is to understand the concept and then be able to apply. And therefore, I feel what we have discussed today has given us some independence in terms of reasoning and the application of concepts to physics for a body which is moving on an inclined plane. And therefore, we thank you. Next time we'll apply now these concepts by solving actually a question. I thank you. Ensure that you subscribe to my YouTube, and furthermore, those who want to contact me for intensive online lessons, this is my email address, lessons-Siamasaka@gmail.com. Thank you.